Philip James Edwins Peebles, Jim to everyone, was all angles, tall and trim. He explained himself to the world through his elbow and knees. He would throw his arm wide, as if to embrace everyone's possibilities, then wrap them around his leg, as if to consolidate the energy and focus. Mannerism not inconism with a man of conflicting sensibilities, which was how Jim Peebles saw himself. Politically, he called himself a bleeding heart liberal, yet scientifically he identified himself as very conservative, even reactionary. He had learned from his mentor, Bob Dick, that a theory can be as speculative as you like, but it doesn't lead to an experiment in the near future. Why bother? On one occasion, Peebles has mentioned that he might try to reconcile the two great physics theories of the 20th century, general relative and quantum mechanics. Go find your Nobel Prize, Dick answered, and then come back to do real physics. Cosmology, to Peebles, was not real physics. It was reversion to how scientists did science in the 2 millennials before there were scientists and science as we know them. Ancient astronomers called their method saving the appearance. Modern scientists might call it doing the best you could under impossible circumstances. When Plato challenged his students in 4th century BC to describe the motion of his celestial bodies through the geometry, he didn't expect the answer on paper to represent what was exactly happening in the heavens. The knowledge was unknowable because it was unattainable. You couldn't go into the sky and explain it to yourself. What Plato wanted instead was an approximation of the knowledge. He wanted his student to try to find the math to match not the fact but the appearance. One student, Eudoxus, arrived at an answer that in one form or another would survive for 2,000 years. For mathematics purpose, he imagined the heavens as a series of nesting, concentric, transparent spheres. Some of these spheres carried the heavenly bodies, others instead with those spheres to retard or accelerate their motions. In order to account for the appearance that he heavenly body all slow down or speed up throughout their orbits, Eudoxus assigned the sun and the moon 3 spheres each, to each of the 5 planets, Mercury, Venus, Mars, Saturn, and Jupiter. He assigned an extra sphere to accommodate the appearance that they sometimes briefly reverse their motion against the backdrop of stars, moving east to west from night to night rather than west to east. And then he added a sphere for the realms of the stars. In the end, his system consisted of 27 spheres. Other students of Plato's, Aristotle, amended the system. He assumed the spheres were not just mathematic constructed but physical relative. To accommodate the mechanics of interlocking system, he added counter-turning spheres. His total 56, around AD 150. Ptolemy of Alexander assumed the task of compiling the existing astronomical wisdom and simplified it, and he succeeded. His night sky was overrun with only 40 spheres. The math still didn't match the parents exactly, but close enough was good enough, as good as it was ever going to be. Today, the 1543 publication On the Revolution of the Heavenly Sphere by Polish astronomer Nicholas Copernicus is synonymous with the invention of a new universe, the Copernican revolution. It was becoming a symbol of defiance against the church's teaching, but it was the church itself had invented the Copernicus to come up with a new math for the motions in the heavens, and it had done so for a sensible reason. The appearance once again needed saving. Over the centuries, the slight inconsistencies in the Ptolemaic versions, the areas where the math departed from the motions, had led to a gradual drift in the calendar, until seasons diverged from their traditional dates by weeks. Copernicus' work allowed the Church to reform the calendar in 1582, incorporating his math while dispensing with the notion of sun-centered universe. Like the ancients, Copernicus wasn't proposing a new universe, either physically or philosophically. Instead, he was formulating a new way to save the appearance of existing universe. The true motion that universe, however, was out of reach, has always been out of reach, and will always be out of reach.